In this video, I'll be covering how to solve question 1, part D from the 2022 AP Calculus AB calculator required free response section. So I covered sections A through C in a previous video, so you can go back and watch that. But this question is talking just about part D. Part D's got quite a bit going on, and it's also worth 4 points out of the full 9 points you can earn for question 1. So let's talk through this problem and see what we can do to get all 4 of our points. So this question tells us that a line forms whenever A of t is greater than or equal to 400, and the number of vehicles in the line at time t for this given interval here, so not forever, but just for this little time interval here, is given by this formula. So n of t equals the integral from a to t of a of x minus 400 dx. And they tell us that a is the time when the line first begins to form. Then they're saying to the nearest whole number, find the greatest number of vehicles in line over this given time interval right here. And then they want us to justify our answer. Whenever somebody wants me to find the greatest amount of something, a max or a min, I basically have 2 options. Option 1 is I could run a first derivative test. I'm just going to call it a first D test. That would be if I want to find local maxes and mins. The other thing I could run is I could do the absolute max-min process. The absolute max-min process is going to be used if I've got an interval to work with, because it's slightly different than the first derivative test. And so if you've got an interval to work with, that's usually going to be where you want to go. And since we have an interval on this problem, we're going to run the absolute max-min process here to find out our answer. So to do that, what we would do is step 1 is we would need to find the derivative. So in this problem, we are trying to find the greatest amount of cars in line. So we're trying to maximize this formula here. This n of t is equal to the integral from a to t of a of x minus 400 dx. So to find the derivative, to find our n prime of t right now, we're going to be using that Fundamental Theorem of Calculus part 1. Really, when you go to take a derivative of an integral, and especially when you're going from a constant, remember a is just a number, it's the lower bound of the interval we care about, to a variable up here, really the only time you ever take the derivative of an integral is when we're doing this the Fundamental Theorem of Calculus Part 1. You just got to know that that's kind of like bells and whistles should be going off right now. So because we needed to find the derivative of this side, and whenever we do to one side, we have to do to the other. That's how we keep things balanced in math. So taking the derivative of the left side, the derivative of n of t is n prime of t. Working our fundamental theorem of calculus on the right side, when I take the derivative of an antiderivative, those are inverses of each other. It's like squaring a square root, right? They cancel each other out, and whatever's inside there comes out as our answer. So same idea here. I'm going to take the derivative of my antiderivative. Those things cancel out, and then whatever's up in that top there, that just drops into our formula. So a of t minus 400. That's our derivative equation. Then step 2 of finding an absolute max or min is to find the critical values. So critical values occur when your first derivative equals 0. So we have our first derivative, and now we just need to set it equal to 0. And from there, we know a of t. A of t was the equation they started us with back at the beginning, so we can actually plug that in here. So 450 square root of the sine of 0.62 t, and then minus 400. Well, lucky for us, this is a calculator required section, so we've got our calculator to use, which is going to make solving that little algebra problem quick and easy. What we'll do, this is what I just refer to as a something equals something. Anytime you want to find out where 2 somethings are equal, you can calculate their intersect. So in y1, I'm going to put our original equation, minus 400, and then in y2, I'm going to put 0. And then from there, I'm going to graph that. So this is kind of step 1, put those in. Step 2, graph it. And then step 3, we're now going to hit second calc, and we'll calculate the intersects. We'll choose the number 5 option, which is intersect. So let's open up our calculator. If, we had done parts A through C already, so ideally you still have that equation in your y1, the starting part of it, so we don't have to retype that in. Again, we replace the t with an x when we're doing graphing just because our calculator doesn't like t's, but then we just need to add the minus 400 at the end, so minus 400, and I want to know when is that equal to 0. From there, I hit the graph button, and I can see my two intersects happening on the right. We know that those are the ones we want. One, because we're never going to deal in negative time on a problem like this. And two is this model only worked from 5 a.m. to 10 a.m., right? So we only care about intersects that were happening from t equals 0 to t equals 5 because it was hours after 5 a.m. And so we know that those two intersects on the right are the two intersects that are going to be our critical values. So now I'm going to hit second, calc. I'll choose the number 5 option in that menu, which is intersect. The calculator at the bottom of the screen is now going to ask us a series of 3 questions. The first 2 questions I could really care less about. It's saying, is that the first curve? Yep, that's the first curve. Go ahead and hit enter. It's then going to move automatically to the second curve for you and say, is that the second curve? Yep, that's the second curve. Go ahead and hit enter. Then from there, it wants us to guess. This is the important one. When you guess, all you're doing with your guess is just pointing the calculator into the vicinity of where you want it to start looking. It doesn't affect the answer. So from there, I'm going to guess right about there. I hit enter a third and final time. And at the bottom of the screen, I know I will have done it all right because it will say the word intersection. And whatever that x value is going to be our first critical value. So in here, oftentimes when you're doing this work, they like you to kind of take it out to 6 decimal points. How wonderful. So this would be x equals 1.469372. So, oops, we don't want highlighter. X equals 1.469372. That's going to be our first critical value right there. And then we'll go find that other critical value by just repeating that process in the calculator. So we open the calculator back up and we just start over. We hit second, calc. Choose the number 5 option in the menu, intersect. Again, first 2 questions we don't care about. First curve, yep, enter. Second curve, yep, enter. It's the guess that we care about. So then we're going to scroll over here to the right and we'll guess closer to this one. And we hit enter on that. And so then from there, that's going to be 3.597713. And so these are our 2 critical values. And what we know is the lower end here, because wherever it starts getting above 0, this is actually our A value. This is when the line first is going to start right here. And so that's actually going to be our lower bound on this. But what we want to do now is finish up this absolute max-min process. So step 3, step 1 was find the derivative, step 2 was find the critical values. And then step 3 here is we're now going to plug in all the critical values and the endpoints of your interval into the original equation, the thing we're trying to find the max or the min of. And from there, the winner of the greatest, the largest y value is going to end up being our greatest number of vehicles. That would be our absolute max in this situation. So, give myself a little more room over here, putting out the equations we'd be using. We'll start by plugging our critical values, and you're going to plug them into the original equation. So we're plugging them into this starting equation. So we would want to know n of 1.469372. And when you go to do this, remember that the lower one here is where the first time that this starts, where the line begins, because it's the first time that we have a critical value. And then what you would get out of here is technically the bottom is A, so 1.469372, and our top value, function notation works the same no matter if we're dealing with integrals or not. We're plugging in for that t value because this is an n of t formula. So this would be 1.469372 up at the top. and then a of x minus 400 dx. Well, this one we can do without really much trouble at all, because anytime your bounds match here, anytime your upper and your lower bound are the same value, you don't care what the integral is. The answer to all of those integral problems is always going to be 0. So that's the first critical value. We know it's happening at 0, which makes sense. That's where the line first started. Then the next critical value, we would pop in 3.597713, and so then that's now going to be the integral. Our lower bound is the 1.469372, and our upper bound is the 3.59777713. And then we've got our a of x, which we're going to need, so let's go ahead and plug it in. It's the same a of x we've been working with. That was our original equation, so 450 square root of the sine of 0.62 t d, oh, not dt yet, minus 400, and then dx is what we're talking about on this one, so this would be an x inside here. And to do this, we've saw this in a previous video. When we want to go ahead and calculate out an integral, we do that in our calculator. So to do an integral in the calculator, the steps on that is you would take whatever this equation is right here, you would put that in y1. So in y1, we would put that full equation, 450, the square root of the sine of 0.62x, and then minus 400. Then from there, we would graph it. And then step 3 is we would do a second calc, and then we're going to choose the number 7 option, which is the integral of f of x dx. It's going to ask us a series of 3 questions, and then from there, or 2 questions, we'll answer those 2 questions. And then at the bottom of the screen, it's going to say integral of f of x dx equals, and whatever that is, that's going to be our answer. So we open up our calculator, and again, this is why I like doing things in the graphing section, is we've got all the stuff still entered in there. If you do it kind of using that integral function on the front side, you're bound to just click clear and delete a lot of stuff, and then you're just going to end up wasting time retyping it. So we go into the calculator. We already have our equation in there. We're now going to graph that, and we're going to hit this time second calc, and we're going to choose that number 7 option, integral of f of x dx. And so the lower limit is going to be our first critical value, the first place where the line starts, so 1.469372. Then we hit enter. It asks us now for the upper limit. That's going to be our second critical value that we found, so 3.597713. We hit enter. And out of there at the bottom of the screen, you'll see that it says integral of f of x dx equals 71.254. So that's going to be that. Technically, this would just be 71 cars. You're not going to have 0.254 of a car. So those are our 2 critical values taken care of. And then from there, we also need to calculate what's happening at n of our other endpoint. So the other endpoint on here is 4. That's the other place that we could possibly have a max going on. So we're going to do the integral from 1.469372 up to 4 of this equation, 0.62x minus 400. We're going to run the same set of steps that we already ran. And again, this is why it's nice to do this work in the calculator. So we've already got our equation in there in y1. Again, we've already got it graphed, and now we just need to hit second calc. And again, choose the number 7 option, integral of f of x dx. Enter the lower limit, 1.469372. Enter the upper limit, which is now 4. Hit enter. And at the bottom now, it's telling us that we have 62.338. So again, that would just be 62 cars in general. We don't have 0.338 of a car. So now we compare all these y values. Remember, it's funky because you're dealing with an integral, but these are y values. So this is the largest. And so the maximum, the greatest number of vehicles would be 71 cars or vehicles, whatever you want to call them. So 71 vehicles would be the greatest number. And as we talk through kind of where would we get points on a test question like this, you're going to get 1 point from being back here, finding that your derivative is set equal to 0, right? So that a of t, oops, oh no, so no prime there. I'm not sure why I just drew that. I was just trying to grab this. So this right here, this is going to get us 1 point from putting that information down. Finding these critical values out here, that's where you would earn a 2nd point on this question. Then running through this portion of the process over here, showing that you plugged in all your values, that's going to get you 1 point. And then coming up with your final conclusion right there, that would get you your 4th and final point. So then this is question 1, part D, 4 points. It's a lot of the points on that 9-point question. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.